Today I will discuss about multiple linear regression model, that is MLR model, in part 1, and in the next I will discuss about Wald test in part 2 by manually and using Python, SPSS and with R code. Hello friends, I am Dr. Nazrul Islam, Associate Professor, Department of Geography, Kuzbehar Panchanan Burma University. First, we have to define multiple linear regression and its discussion, and afterwards we will test Wald test. So, multiple linear regression is a statistical technique used to analyze the relationship between a dependent variable and two or more independent variables. It is an extension of simple linear regression. The goal of multiple linear regression is to estimate the coefficients beta 0, beta 1, beta 2, beta 3 up to beta n that best fit the data, and it is used to show the relationship between multiple independent or explanatory variables, that is x1, x2, x3, etc., and a single dependent, that is response variable y. So, by using multiple linear regression, we can see what the relative influence of one variable is another. For instance, we can see if the number of rooms in a house affects price holding all else equal. If we only have one variable affecting our dependent variable, that is housing prices, we would be creating a simple linear regression model. But what if we believe that more than one thing affects housing prices, that is view, neighborhood, location to the nearest city, etc. This is where multiple regression becomes a great tool. Thus, multiple regression can take many independent variables into a model to explain how those independent variables affect the dependent variable. For this, we have taken an example where household income is the response variable or dependent variable, and education level x1, years of work experience x2, and number of dependents x3 are the independent or explanatory variables. These are the database we will discuss later. So this is the tabulation. We have taken three independent x1, x2, x3 variables and one is dependent variable, that is income in 1000 rupees. So we will determine the summation of all the independent and dependent variables as well as the mean of these variables. Then we will determine x minus bar x1, x minus bar x2, x minus bar x3, y minus bar y. That is, bar y is the mean of y. Next, we will define the deviation square of all the independent as well as the dependent variables. These are the square values, and we will sum these values. Then we will multiply it by x1 minus bar x1 multiplied by yi minus y bar, x2 minus bar x2 multiplied by yi minus y bar, x3 minus bar x3 multiplied by yi minus bar y. Then all are these taken as summation value we will get here. Then we will determine beta 0, and in the later stage I will show you how to determine beta 0. Beta 0 is the intercept, y-intercept, and then we will determine the predicted y or hat y. This is the formula by using we will determine the predicted y or hat y. Then we will determine residual. It is called error term, and it is determined by yi minus hat y, and we will get this data. Then we will determine epsilon square, that is residual square, and we will get the sum value epsilon square, that as 15.494. It is called sum squared error. Here we will use several steps for calculating multiple linear regression. The first step show the formula of predicted y, that is beta 0 plus beta 1 multiplied by x1, beta 2 multiplied by x2 plus beta 3 multiplied by x3 plus beta n multiplied by xn plus epsilon. Epsilon is the error term, and beta 1, beta 2, beta 3 up to beta n are the coefficient of independent variables, and beta is the y-intercept. In step 2, we have to determine beta 0, beta 1, and beta 2, beta 3, and epsilon also. Using complex formulae, we can get coefficients of independent variable of x1, x2, and x3, and they provide similar result by using Python spaces and R code. The results are beta 1 equal to 1.1621, beta 2 equal to 2.6589, beta 3 equal to 0.5031. By substituting the value of beta 1, beta 2, and beta 3 in the formula of beta 0, we will get a result of 12.8424. Here to note that the intercept, often denoted by beta 0, this is beta 0, is one of the coefficients in the regression equation. It represents the value of the dependent variable of y when all independent variables x1, x2, and x3 are equal to 0. In other words, the intercept is the predicted value of y when there is no influence from any of the independent variables. In step 3, we have to determine the predicted y by using the following formula: y hat equal to beta 0 plus beta 1 multiplied by x1 plus beta 2 multiplied by x2 plus beta 3 multiplied by x3 plus error term, as we have explained here in the case. Step 4 is the determination of residual, that is epsilon I. In regression analysis, residuals, also known as errors, are the differences between the observed values of y, that is actual data points, and those predicted by a regression model. They represent the unexplained variation or noise in the data. In other words, residuals indicate how far the model's predictions are from the actual data points. So formula of residual is yi, that is observed value of y, and hat y, or the predicted value of y, that is hat y. So in the next step, we will determine the sum squared error SSE and sum squared or residuals. Both are same, and we have seen in the previous table that epsilon square summation is called sum of squared error, that is 15.4942. It is also called error term or residual. In step 6, we will determine the variances of x's. As you know, there are three independent variables x1, x2, and x3, and these are the formula: summation x1 minus bar x1 square divided by n minus 1, where n is the number of observations and Here n is 10 and the value is 7.067. Similarly, we get the variances of x2 as 7.067 and x3 as 0.90. In step 7, we determine the standardized error or error term by using the formula uh, under root SAC divided by n minus k multiplied by variance of x1. Here to note that n is the number of data points, that is 10 in this case, and k is the number of independent variables, 3 in this case. So we have get the SSE here as well as in the table, that's 15.4942 divided by 10 minus 3 multiplied by variances of x's, and we will get the result 0.55967. Standard error of beta 2 also 0.55967, and standardized error of beta 3 is equal to 1.56825. In step 8, we determine the correlation coefficient between and among the of the dependent and independent variables. Here Rx1, by using this formula, we get the Rx1 as 0.9827, Rx2 0.9907, and Rx3 equal to 0.6539. Now we interpret the result of correlation coefficient, that is R values, in multiple linear regression model. Here correlation coefficients measure the strength and direction of the linear relationship between two variables. A high R value such as Rx1 equal to 0.9827, Rx2 0.9907 indicates a strong linear correlation between the independent variables x1 and x2 and dependent variable y. Similarly, Rx3 value is 0.6539, reflects a moderate positive linear relationship between x3 and y. It implies that there is a strong to moderate linear association between the predictor variables and the response variable. Here to note that high correlation coefficients R values indicate the presence of linear relationship, which is necessary but not sufficient condition for causation or predictive power. It may sometimes yield a nonsense association. For this reason, we have to perform a statistical test to assess this relationship statistical significance in the context of linear regression model. The Wald test focuses on whether the coefficients of the predictive variables of x1, x2 and x3 are necessary for explaining y in the multiple linear regression model. Here is the Python code for determination of MLR model. We have to determine beta 0, beta 1, beta 2 and beta 3 by using this code, and this code give us the result as we have calculated manually. Again, we are also determine the Rx1, Rx2 and Rx3 by using this part of Python code, and this will also give us the similar result as we have calculated manually. In this code, we will determine the variances of x1, x2 and x3, and this is the code and these are the results. Next, we have to determine the standardized error AC of beta 1, beta 2 and beta 3. This is the code and these are the result similar to manual calculation. This is the Python code for determination of predicted y or y hat, and by using this code you will get the result of predicted y, and this is also similar to the manual calculation. This is the Python code for plotting. If you want to plot the predicted y against actual y and as well as the predicted y as well as residual, you will get by using this code and for plotting. This yield the result of graph of actual y against predicted y, and this is actual y and residuals. So we can also perform multiple linear regression by using SPSS. There are several steps. First, open your dataset in Excel and launch your SPSS of any version, preferably more than 20 version. Open your dataset by going to File, Open and Data, navigate to the regression menu, then go to Analyze and choose under Analyze you can find regression and then click Linear. Now in step 4 you have specified a dependent variable. As you know, y is the dependent variable, and um, really, your dependent variable should go to this dialog box. And in step 5, select the independent variables predictors from your dataset and move them to the independence box. These are x1, x2 and x3. Now you have to check options. Click the statistics button. Here you can request several statistical output as you require. For basic linear regression analysis, you can leave the default setting, as well as you will also click the save button and check the other parameters. Then run the analysis, click OK for run analysis, and you will get the output in SPSS. This is the SPSS output by performing the database, and this is the descriptive statistics. This is the correlation matrix table, and you will find as the education level x1 with y is 0.983, years of experience x2 as 0.991, and number of dependents 0.654, and these are the results. As this is the model summary of R and R square. This is the ANOVA table. We did not discuss about ANOVA in this case, and this is the coefficient as I have mentioned. Beta 0 is the 12.842, beta 1 is the 1.162, beta 2 is the 2.659, and beta 3 is the 0.503. This is the R code for calculation of multiple linear regression model, and you will get the result as summary model as well as predicted y values. Follow part 2 for Wald test. It will also be calculated manually, Python, SPSS and with R code. Thank you for watching my channel. Please subscribe my channel.